With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question, it is given that the standard potentials of various couples are given. Like you can see here, from AU plus to AU, that is the standard reduction potential is given plus 1.69 volt. Then AU3 plus to AU, the reduction potential is given plus 1.40 volt. And then from Fe3 plus to Fe2 plus, the potential is given plus 0.77 volt. We need to calculate the equilibrium constant for the reaction. 2Fe2 plus gives plus Au3 plus gives 2Fe3 plus Au plus. Fine. And these are the given options for the question. 4 into 10 to the power 16, 8 into 10 to the power 8, 4 into 10 to the power minus 16, and 1 into 10 to the power 14. Right? So let's see. Let's write down the equations first. So the equation which is given is that Au plus gives you Au. This is by the reduction reaction, we know. So this is the one. Then in the other case it is given A3 plus gives Au by removal of 3 electrons. So for here it is plus 1.40 volt, right? So the first one is plus 1.69 volt and the second one is plus 1.40 volt, right? Plus 1.69 volt and plus 1.40 volt. So these are the two equations which we know. Now, if you will see the main equation, here you have the conversion from Au3 plus to Au plus. So we need the reduction potential of this reaction, which is Au3 plus to Au plus by the removal of 2 electrons, right? This reduction potential you need to calculate. So how we will calculate this reduction potential? Let's see. We all know that delta G, that is the gives free energy is additive or subtractive in nature. Gives free energy is additive or subtractive in nature with the equation additive or subtractive, right? So we will calculate the delta G1 and delta G2 first for the given reactions. Like if this was 1, this is 2 and this is reaction 3, then delta G1 will be, let's write down what will be delta G1 then. Delta G1 can be written as, we all know the delta G1, the value of delta G1 is minus NFE1, right? Or N1F1E1. What is N? The change in electron. So minus of, what is the change in electron? 1 is the change in electron. So you will write here 1 into F into what is E1? It is plus 1.69. So from here you will get delta G1 value as minus 1.69 F, right? This is delta G1. Now let's write down delta G2. So this will be minus N2FE2, right? So in this case, what is the value of N2? You can see the value of N2 in the second equation, the value of N2, that is 3 electron change into F into what is E2 plus 1.40. So from here you can write, then it is minus 3 into F into 1.40, right? This is the value of G2. Now the value of G3 is minus N3 into F into E3, right? So we know that in the last equation, the change in electron is of 2. So we can say it is minus 2 into F into E3 we don't know. We need to calculate the value of standard reduction potential. Now let's see. So you can say that if you subtract these two equations, right? If you subtract these two equations, then you can get the equation number 3 very well. Au3 plus, if you subtract the equation 1 from equation 2, then you can easily get the equation number 3. So subtract equation, which equation? Equation 1 from 3. 1 from 3. So if you subtract this equation 1 from equation 3, then you can easily get that Au plus Au3 plus will give you AU plus, right? This is what is the last equation, and subtracting you will get this equation. AU3 plus will give you AU plus. Now this will be delta G3, which can be written as, since you have subtracted equation 1 from equation 3, equation 1 from equation 2, so you can write down, this is equation 2, so you can write down there that delta G3 is nothing but delta G2 minus delta G1, right? You can write like this, delta G2 minus delta G1 will be equals to delta G3. So from here, you can say the value of delta G3 we have calculated here. The value of delta G3 is minus 2 times into F into E3. This will be equals to, what is delta G2? It is minus 3 into F into 1.40 minus. What is delta G1? You can write down delta G1 is minus 1.69 F. So from here you can easily calculate the value of E3 will be, this F will be cancelled out throughout the equation, and finally you can write down E3 can be, this minus will go that side, so you can write down 3 by 2 into 1.40 minus 1.69 by 2, right? We have taken this minus 2 minus that side, that is on the right hand side. So this will be 3 by 2 into 1.40 minus 1.69 divided by 2. So this much volt will be the value of E3. Now we all know from the main equation that in the main equation you can see the Fe2 plus is getting oxidized to Fe3 plus. So this is the main equation, 2Fe2 plus Au3 plus is getting oxidized to 2Fe3 plus Au plus, right? This is the equation. So we have calculated the reduction potential of this equation, right? This equation reduction potential we have just calculated as E3, right? Now what we need to calculate is the oxidation potential of this equation, right, from Fe2 plus to Fe3 plus. So we have been given, see, in the question we have been given that Fe3 plus to Fe2 plus, that is the reduction potential is 0.77 volt, right? We have been given 0.7 volt. So E of Fe3 plus to Fe2 plus, that is the reduction potential is given 0.77 volt. So from here you can say that E of Fe2 plus to Fe3 plus, that is the oxidation potential will be the negative of the reduction potential, that is minus 0.77 volt. So this is what I wanted to write down. So from Fe2 plus to Fe3 plus it will be minus 0.77 volt. So finally E naught, that is the standard potential of the cell, can be written as E of oxidation plus E of reduction, right? So from here we can see what is E of oxidation. E of oxidation is written as minus 0.77. You can see here the Fe2 plus is getting oxidized, so this is only E of oxidation, and E of reduction can be written as plus 3 by 2 into 1.40 minus 1.69 by 2, right? This is the value of E of reduction of Au3 plus to Au plus. So from there you will get the value of E naught of cell as, so the value of E naught of cell from here you will get it as 0.49 volt, right? This will be the value of E naught of cell. Now we all know this in relation. What is the relation? That log of Kc, that is the log of the equilibrium constant, is n times of E naught of cell into F divided by RT. So this is the important relation. We should remember this, that log of Kc is equals to times of E naught of cell into F by RT in case of equilibrium. So let's write down what is the value of F by RT. The value of RT by F is 0.059. So from here you can write down the value of F by RT will be reciprocal of 0.9. So finally this can be written, this equation can be written as N into E naught of cell divided by 0.059. Now our aim is to see what is the value of N. N is the number of change of electron, number of change of electron. So let's see number of change of electron. So in this equation you can easily see here that the change of electron from 3 to Au plus is of 3 or 2. Yes, the change of electron is of 2 from Au3 plus to Au plus, or from Fe2 plus to Fe3 plus. For 1 mole change was 1. So for 2 moles the change is 2 electrons, right? So the change is of 2 electron in this case. So you will write the value of n will be equals to 2. So when the value of n is equals to 2, the formula has become like this: log of Kc is equals to change in electron is of 2, so 2. What is the value of E naught of cell? We have already calculated, it is 0.49 divided by, what is the value? It is given 0.059. This is the formula. So from here you can calculate the value of Kc will be equals to anti-log of this whole value 2 into 0.49 divided by 0.059. So from here the value of Kc will come out to be around 4 into 10 to the power 16, right? This will be the value of Kc, 4 into 10 to the power 6, and this is our required answer. So let's check which option is correct. So from here you will get that option A, yes, option A is the correct choice, 4 into 10 to the power 16. So let's write down option 1 is correct, right? I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.